Hi everyone, in this video we're going to be learning how to find the equation of a sine curve. We'll also be learning how to find the equation of a cosine curve. And for that we're going to be working through two examples, the first of which you can see on the screen here. And we're told, given this curve's equation is y, which equals to a times sine of bx plus c, find the value of a, b, and c. In other words, we need to find the value of the three coefficients we see in this sine curve's equation. Now before I start, I should say, the method we'll be using for finding this sine curve's equation will be identical to the method I'll be using in just a couple of minutes to find a cosine curve's equation. Indeed, if you know how to find a sine curve's equation, then you'll know how to find a cosine curve's equation. Nevertheless, I will be working through one example for each for the sake of confirming that statement. All that being said, let's get started. So I'll go ahead and write SOL here for solution. There we go. And I'll write a little 1 since that's the first question we're answering. Now for this question 1, we're told that we need to find the value of the coefficient a. Now looking at our sine curve here, that's the number that's multiplying the sine function. And this number a, well, it's known as the amplitude. And luckily for us, there's a convenient formula for it. And here it is. A, and I'll just write that a, is equal to the maximum y-coordinate we see on the curve, so I'll say y sub max, minus the minimum y-coordinate we can see on the curve, so y sub min, over 2. And I'll go ahead and box that formula. Do make a note of it. There we go. Now looking at the sine curve we're given here, we quickly see that the maximum y-coordinate we can see on the curve is 4. Indeed, we can see a 4 here and a 4 here. And the minimum y-coordinate we see, well, that's equal to negative 2, which we can see at these 2 points here. So copying this formula but replacing y max by 4 and y min by negative 2, this becomes a, which equals to 4 minus negative 2. And all that's over 2. Now, since when we subtract something negative it turns into an addition, this becomes 4 plus 2 over 2. And now 4 plus 2 of course is 6, so that's 6 over 2. And finally the amplitude a is equal to 3. And that's the answer. So at this stage we know that our sine curve looks something like this. Y equals to 3 times sine of bx plus c. That being said, I carry on. Question 2 here, there we go. We need to find the value of the coefficient b. So that's the number inside the sine function which is multiplying x. Now in mathematics, b is known as the angular frequency. In physics or in engineering, we tend to call it the wave number. And the role of the wave number, or b, is to tell us how many full cycles our curve does every 360 degrees. So if b were equal to 3, for example, then the curve would do 3 full cycles every 360 degrees. Or if b were equal to 20, then it would do 20 full cycles every 360 degrees. And luckily for us, there's a formula for b as well. And here it is. b is equal to 360 over capital T. And I'll go ahead and box that formula as well. There we go. And in this formula, this capital T is the sine curve's period. Or in physics or engineering, we also call that the wavelength. And this period or wavelength, capital T, tells us how long it takes before the curve starts repeating itself. In other words, it tells us the length of a full cycle. And to find the period from the curve we have here, all we need is to find 2 corresponding points from one cycle to the next. Here's what I mean. I could take this maximum point here as well as this maximum point here, and the period will be the horizontal distance that separates those 2 points. In other words, that distance there is capital T. And I'll definitely use these 2 points here because, well, I clearly have their coordinates labeled here. But I should say, you don't necessarily have to take the maximum points on your sine curve. For instance, I could choose to take this point here and its corresponding point in the next cycle right here. And the period t would also be equal to this distance here. But in this example, it definitely seems more convenient to use these 2 points. Now to find the value of capital T, I need to focus on the horizontal or x-coordinates of these 2 points. Here I can see that the one furthest to the right has an x-coordinate of 225, and the one to the left here has an x-coordinate of 45. And consequently, the period capital T will be equal to 225 minus 45. In other words, it's the difference of those 2 points' x-coordinates. Now, 225 minus 45 is equal to 180, So the period here is equal to 180. And I suppose I should be more specific and state 180 degrees. And I'll go ahead and box that intermediate result. In fact, I could have added this as a question here, find this curve's period, and this would have been how we'd answer that. Back to the value of b. Now that we know that the period is 180, we can use our formula to state that b, the wave number, is equal to 360 over 180. So b is equal to 2. And I'll go ahead and box that result. There we go. And so at this stage, we now know that our sine curve looks something like this. Y equals to 3 times sine of 2x plus c. Finally, I move on to the last coefficient, so question 3 here, in which we need to find the value of c. And c is the number that's being added at the end of our sine curve here. And once more, luckily for us, there's a formula to find that value c as well. Indeed, c is equal to the maximum y-coordinate we see plus the minimum y-coordinate we see over 2. In other words, c is the average height of our sine curve. And so I'll go ahead and box that formula. Do make a note of it as well. There we go. And now, just as we saw for the a coefficient over here, the maximum y-coordinate on this curve is 4, and the minimum y-coordinate on this curve is negative 2. And so using those two values, we can quickly say that c is equal to 4 plus negative 2 over 2. And now 4 plus negative 2 is 4 minus 2, and that's still over 2. And that quickly becomes 4 minus 2, which is 2 over 2. In other words, c is equal to 1. And we now have the third coefficient. And we can now state this curve's full equation, and I'll write it right here. Indeed, this sine curve's equation is y equals to 3 times sine of 2x plus 1. And I'll go ahead and box that final answer. Now, this plus 1 at the end here, in other words, the value of c we just found, tells us the amount by which this sine curve has been shifted upwards, or downwards if it were negative, away from the x-axis. And if I were to draw the line y equals to 1 on this xy grid here, it would look something like this. We'd have this line here, that's y equals to 1. There we go. And you can see here that this sine curve is oscillating on either side of that y equals to 1 line. And the amplitude a equals to 3 is the distance that separates the maximum point as well as the minimum point from this line y equals to 1. And in fact, I could illustrate that here. This distance here is a, which equals to 3, that's the amplitude, and we can see that vertical distance right here as well. Indeed, that's the amplitude, a equals to 3. And there we go. We've now found this sine curve's equation, y equals to 3 sine of 2x plus 1. Now, as I said at the beginning, if we know how to find a sine curve's equation, then the method for finding a cosine curve's equation is identical. And to confirm that statement, let's work through a second example now in which I find a cosine curve's equation. And so let me start a fresh page here. Okay, now on this second page here, we're faced with our second example, in which we're told, given this curve's equation is y, which equals to a cos bx plus c, or y equals to a times cosine of bx plus c, we need to find the value of a, b, and c. And of course, we can see the cosine curve right here. And once more, I'll go ahead and write SOL here for solution, SOL. And we're ready to get started. So question 1, again, we need to find the value of a, which once more is the amplitude of this curve. So the formula is the same. I can go ahead and state that a is equal to y max, so the maximum y-coordinate, minus y min, which is the minimum y-coordinate on the curve, over 2. And again, I'll go ahead and box that one as well. There we go. And so let's see. The maximum y-coordinate we can see on this curve, well, it's labeled 3 times for us here, but I'm sure you can see it's 6. Indeed, we have 6 here, and 6 here. On the other hand, the minimum y-coordinate we see here, well, that's negative 2, which we can see on these 3 points. And so, copying this formula but replacing y max by 6 and y min by negative 2, this becomes 6 minus negative 2 over 2. Now, since 6 minus negative 2 turns into 6 plus 2 over 2, this quickly becomes 8 over 2. In other words, a, the amplitude, is equal to 4. And I'll go ahead and box that result. There we go. So at this stage, we know that this cosine curve's equation looks like y equals to 4 times cosine of bx plus c. And so I move on to question 2. In question 2, remember, we need to find the value of b, which is the angular frequency or wave number for this cosine curve. I'll remind us of the formula again. The formula for b is equal to 360 over the period capital T. And again, I'll box that formula. There we go. Now to find the period, I'll go ahead and take this maximum point here and this one right here. And the period is equal to the horizontal distance separating those 2 points. So I'll just label that capital T there. And let's see, I'll write capital T here. Now, to find the horizontal distance, I focus on the x-coordinates of those 2 points. So I can see that the one furthest to the right has an x-coordinate of 240, and the one to the left here has an x-coordinate of 120. So the period capital T is equal to 240 minus 120. In other words, the period capital T is equal to 120 degrees. And again, I'll box that result as well. There we go. Now that we have the period 120, we can find the value of b thanks to this formula, and we can quickly state that b is equal to 360 over 120, and 360 divided by 120, well, that's 3. So b is equal to 3. And I'll go ahead and box that result. There we go. And so at this stage, we know that our cosine curve looks like this. Y equals to 4 times cosine of 3x plus c. And so we move on to the third and final part of this question, in which we need to find the value of the coefficient c. Remember, that's the number that's being added at the end of our function here. And again, there's the formula that we saw for the previous example. C is equal to y max plus y min over 2. In other words, it's the average of the maximum and minimum point on our curve. Well, the maximum y-coordinate and the minimum y-coordinate haven't changed. Indeed, they should still be equal to 6 and negative 2. And so using those values here, that quickly turns into 6 plus negative 2 over 2. And 6 plus negative 2, well, that's the same thing as 6 minus 2, and that's still over 2. 6 minus 2 is 4, so that's 4 over 2. And finally, c is equal to 2. And that's the answer. And just as I did for the previous example, I like to draw the line y equals to c, so in this case y equals to 2 on my curve. So that would be this horizontal line right here. There we go. That's y, which equals to 2. And I'll know if I found the right value here because this line should be equidistant, in other words, is at the same distance from the maximum points on this curve and the minimum points of this curve, which looking at this, they clearly are. And the distance that separates the maximum and the minimum points of this curve from this line y equals to 2, well, it's the amplitude, which again I could draw right here. That distance here is the amplitude, which equals to 4, which we can see here as well. A equals to 4. And there we go. Now I should finish by stating this curve's equation, and I'll write it right here. Y is equal to 4 times cosine of 3x plus 2. And that's the final answer. And that's it for these examples on finding the equation of a sine curve and a cosine curve. And there we have it. There we go, everyone. I really hope that helped, and if it did, please hit like on this video, drop a comment down below, and even subscribe to this channel to help get this video out to as many students as possible. All that being said, that's it for this tutorial.